Welcome back. This is Mr. Greenstein's Geometry. Let's talk about, this is section 12.5 and part 2. Let's talk about a number that's very important. It's this thing called a factorial. And it's the product of the integers from 1 to n, and this is only positive integers. It's the product of all those. So in this particular case, I say n factorial, and we use the exclamation mark to show factorial. It's going to be whatever the number is times 1 less than that, all the way down until we get to 1. So here's an example. The 4 factorial would be 4, then 3, then 2, then 1, and multiply them all together, we get 24. There's a special case where 0 can be a factorial, but it will produce the number 1. So 0 factorial produces the number 1, whereas all the other integer numbers 1 on up is going to be just like in the case where the 4 factorial. And we're going to use this. Permutation formulas. So if the number of permutations of n objects, if we have n objects, we want all the different permutations, just like our flipping the coin, then that's given by this formula. We have n objects and we're choosing n of them. So then it looks like this. N objects choose n objects, permutations is equal to n factorial. So the permutations of the letters of the word July are going to be 4 factorial because there's 4 letters. So that's going to equal 4 times 3 times 2 times 1, which is equal to 24. The number of permutations of n objects taken r at a time. So instead of taking all of them, maybe we only want to take some of them, where r is less than or equal to n, is given by this formula. We have n objects, and we're going to pick out r at a time, just some smaller number of them. Then it's n factorial over n minus r factorial. So here's an example, the permutations of 2 of the letters of the word July. So what we'll do is we'll say this is the same thing as the permutations of 4 things, that's the 4 letters, and we're going to choose 2 of them at a time. So that equals 4 factorial over 4 minus 2 factorial. And when you divide all of that out, you get 12, just like we got before. Except here's our formula. Let's calculate the 10-horse race. If 10 horses are running in a race, and how many ways can the horses finish first, second, and third? So that's 1, 2, and 3. So then we have the permutation of 10 horses, and we're going to choose out 3 for those 3 winning places. So that's going to be 10 factorial over 10 minus 3 factorial. And that's the same thing as saying 10 times 9 times 8 times 7 factorial. Remember, the 7 keeps on going all the way down to 1 over 7 factorial. So we can cancel out the 7 factorial and multiply all the rest of that together, and we get 720 different ways that these 10 horses could be chosen at random, first, second, and third. Now here we have 12 school floats in a parade. How many ways can the floats be ordered in the parade? What that is just we have 12, and we're going to order all 12 of them, so all the different ways we can do that is going to be 12 factorial over 12 minus 12 factorial. And that's the same thing as 12 factorial over 0 factorial, or 1, and that comes out to be the number 479,001 600. So there are 479,001,600 different ways that you could order the floats. That's a lot. The floats will be judged first, second, third, and fourth. How many ways can the floats place? Well, here's another case of permutations where we have 12, but we're only going to choose 4. So in this case, we have 12 factorial over 12 minus 4 factorial. And that's the same thing as saying 12 times 11 times 10 times 9 times 8 factorial, all over 8 factorial. So they cancel out. And this turns out to be a little smaller number, still a large number, 11,880 different ways that they can place first through fourth. And then finally, suppose that you represent the math club and your friend's float is the swim club. What is the probability that your float will be first place and your friend's float will take second place? Well, what we have to do is we have to consider that there's only one possibility of that happening, but there are a whole bunch of ways that the other 10 floats could be represented. So really, this is about having 10 factorial, and we're talking about probability here, 10 factorial, and that's all the different ways that the other floats could be arranged, over all the possible outcomes, which is 12 factorial. And when we multiply that together, we have 10 factorial over 12 times 11 times 10 factorial, where the 10 factorials get canceled out. And that will be 1 over 132 different is the probability that you will take first place and your friend will take second place. And we'll continue this conversation in the next video.